Hello, everyone, and good evening to all of you. Welcome to Season of Agents, a virtual event dedicated to exploring the dynamic world of intelligent agents, automation, and the future of AI powered productivity. Today, we are delighted to have Bhushan sir with us, who is lead data scientist at Optum, to take us on this exciting journey of AI agents. So, without any further ado, handing over the session command to sir and welcoming him and inviting him to take us on this exciting journey.
Okay. Thank you, Sudhanshu, for the brief introduction about me and talking about the seasons of agent. So, as we are evolving over the agentic era, where the agent has been playing an important role, so I'm going to talk more about the agents, and I hope that community gets benefited with the same. Uh, before let's start with the particular presentation and things. Try to explain that what I'm going to uh, today. Yes, let me share my screen. Okay. Uh, So today we are going to talk more on the autogen side of it, where we thought as the agentic frameworks are coming a lot over there. So we are going to talk more on the agentic framework. Different agentic frameworks are this. Autogen is a majorly a Microsoft agentic framework, and we are going to you understand that in deeper and trying to go much more granular part of it and try to understand how it's going to impact it. So. Let me introduce myself in brief little bit, and then we can go deeper into the same. So about me, my name is Bhushan Kapkar. So I'm working as a senior GenAI architect, very enthusiastic about the AI technologies and open source project, as solving a business problems to for the problem and the community engagement. So I have been associated with the different communities like HYD Pike, PyCon Hyderabad, PyCon India, PyCon, and the AWS work groups as well. So we generally conduct the similar kind of meetups and hackathons in the industry so that everyone can be get benefited over there. So it's been nearly 10 plus years of experience. I have been in the industries, and I love to mentor the community where whoever wants help and try to help them out. Okay, let's get started about the agenda today. So what we are going to talk about is more about the what our agents are and understanding the core concept behind the agents. What are the building blocks? So generally, the agents are been consist of so many things, and we wanted to join the different pieces over there, and we try to understand that what are different uh, blocks available over there, and then further we will talk about agentic frameworks. So there are multiple agentic frameworks available in the market, how things are different for one different agentic framework, and how this particular autogen is different for this from other agentic frameworks. And then probably we'll go into the hands-on session where we try to see how exactly we need to code for this using the autogen. So that's how we will start with the entire thing. So as a agent in IL, so as we've seen, the things has been grown from the generative AI to more into the agentic one, where we try to see that it's more about it's previously when it started, it's more about the chatbot where we just have the conversation, and the chatbot used to get the response or the but in terms of the agent, it's more than the chatbot. It's a complete autonomous system. So there are the multiple LLMs available in the markets, and or the where we could assign a different tasks to the LLMs. We could use a different leverage tool, the available memories which that particular agent can have, and all these particular reasoning capabilities, and try and assign certain tasks to it, and so that we could reach the particular goal. So this entire ecosystem, when we talk about it, is that's what we call the agent. It's not a single conversation of a chatbot kind of thing. It's more about the autonomous system where we try to leverage it and automate the process over there. So it can act as a as you mentioned the key traits. Its act can be act without a human consent, and it could work independently over there. It read the environments. It could drive the or it could install the libraries into the system, we could given a specific task and the goals for the models, and it could do that one. It's more about also interactive one, where you could also get intervention and talk to users and other agents. When we talk about the action oriented, different tools, server APIs and other manual tool can also be developed and integrated into the system. So where do we use this particular agent? So generally we use for the virtual assistants, game AI, robotics, autonomous vehicles, multi-agentic systems. So there we all these particular agents we use. So generally if you see this particular process flow, so we have given certain agent certain task or the goal, and then it uses RAG. It called different functions available, which we could configure into the autogen, and then passes to the LLMs and then responds to the users. So that's how this entire agent of ecosystems work. Let's understand what are the building blocks of particular agent. So there are different tasks which this LLM can complete, and in a complete ecosystem become a complete agentic system. So when we have a certain completion task, like if you give a shortest text over the for the model, and it try to complete the entire text over there, so that's what we call it as a completion API. So it has a completion task over there, where we could have the chat related stuff, where the multi conversations happen, so it could have the chat related stuff. So LLM is the main brain behind this but entire system, where we could have the large language models or different large language models, like from the OpenAI to the Claude to the Llama models. So there are different large language models available in the ecosystem. We try to leverage with this particular AutoGen and other thing. We also have the function calling. So whenever there is a requirement that the model itself is not capable enough for answering that, and we need some external tools to answer that particular question, so then where we use the function calling. When we talk about the plugins tools over there, where we have a different like a calculator, search engine, APIs that could dive there, and the retrieval augmentation generation. So it's more about when we try to use the system where the on the specific knowledge based system, so where we use this retrieval augmentation generation, which we nothing called as a RAG based models. So the thing, and we try to use this agents autonomous LLM driven entity plans to design, collaborate, and complete tasks. So all these particular building blocks are being integrated into the single agents, when and where required we are using and pulling this particular block into our system, and this entire ecosystem is a part of the age for the agents. So that's how we call as a main building blocks for the any agent that we are available in the system. So what are the different frameworks available into the agentic era of currently? There are different frameworks like LangChain, AutoGen, which we are going to talk today, the Crew AI, semantic kernel, and there's one more Agno, which have not been mentioned over there. But since there is a different frameworks, that as you mentioned, that LangChain is available with the Python and the JavaScript as well. So generally for the there is a one more autonomous framework which we call as a LangGraph. It's more of a agentic one, so similar to the LangChain. It's the same companies over there. And what we're talking about more of the AutoGen today. If talk about the QA, it's about the role-based delegations and agentic framework that we could do, and it try to have certain goal based information and try to execute and try to achieve that one, while the semantic kernel is more of a Microsoft main agentic framework, where similarly the Autogen is more of a research based, and the also used in the production level over there. So while the semantic kernel is more of an enterprise level for the Microsoft, and can be used for multi-purpose use. And today, as for the Autogen, as used for the multi-agentic collaboration, tool calling, and task orchestration, we are going deeper into that, how exactly we can do that one. So how do we build this particular autogen agent? So there are different ways with the help of which we could build it. Either we have a Copilot Studio, which is there in the Azure, and in that particular Azure Copilot Studio, you just pull the particular component into the system and try to assign a certain task to it, and then we will able to integrate it. And then whether we could integrate with the Microsoft Team, Power Platform, Dynamics, or any other tools like Outlook, OneDrive, and other thing, we could integrate with the different components of the Microsoft tools. So along with that, Azure AI Foundry, which was more of a advanced version of AI ML, which was been uh, while Azure AI Foundry is more about LLM related stuff and deploying the AI agents and other things. So it is more customize and configure for the AI agents related work, while Azure ML was more of a machine learning related stuff. While the auto agent framework which we are going to learn in today is the multi-agentic orchestration, where we are doing a different tools in calling great for scalable, and the different LLM agents can be configured into this autogen agent framework, which is available in the Python and the C sharp as well. So mostly we are going to cover today in the Python language, as well as the semantic kernel. We could also build it where this particular uh, as it's integrated part of the integrated part of Microsoft, we could also use it in the semantic kernel. So these are the different ways with the help of which we could create the autogen. Mostly we are going to focus today on the autogen framework with the Python, where we could manually code it and try to see that how exactly it performs. These are the things how we wanted to, but what are the things that particular agentic framework can build? So that's where the next task what we'll be talking about. So generally this particular agent frameworks can code, execute, and supervise. So agents can write a code and involve humans when needed. So it can generate a code for you, and it try to run the particular code for it and try to generate the output result for it. uh, Customizable agent types, you could mix the different LLMs and human types over there and try to get the result. Conversable agent can send and receive the message. Is a unified interface, you could have a customizations over there. You could create a multi-agent collaboration, so you could create different reviewers, collaborators, and uh, editors. So different kind of agents and tasks you could decide or the give to this give to task given to the agents, and then it will try to have a group chat among them and try to decide and give come up with the final objective that we have been assigned to the. So it's similar to the sense decide and act, so it could do autonomously observe, plan, act, and achieve the goals of the models. And that's how it tried to give the final result for it. So this is how what we could do in the agentic in the agent framework. Now when we talk about a multi-agent collaboration, so how does that particular things. So when we go into the granular part of it, we there is a certain task we could given to the agent, and that task can be anything that you wanted to do research on the particular topic, whether it's related to AI or whether it's related to some car research or anything. It could be anything. So you give certain tasks to it, and then further to that, there is a role assignment. So that it says that particular you are expert in certain tasks. So if it's you're doing a researcher task, so it might be you are good at you have done the PhD, or then you're good with the particular research task and other thing. So you could assign a certain role to it, and then further once we have decided the task to him and given a role to him, so there is a communication happen between the different agents, which we could see the agent 1, agent 2, and agent 3 inside the loop. And then finally each agent can interacted with each other and give the final output for from the given task. So this is the very high level agent collaboration. If we go a little bit granular of uh, this framework, so that's where how this particular agent look like. So it's about the conversable agent, I would say. So there is a conversable, this is an conversable agent. agent, there is a assistant agent, there's a user proxy agent, and the group chat manager. User proxy agent is nothing like somebody has to act like a human to it. So that agents are nothing but the user proxy agent. They will act as a human. So you could also say that a human input mode, either you need it or you never need it. So it can act autonomously. So if you could see here at the bottom, it said always, and we could also set up a different parameters like never or always. So it depends on what configuration you set for your agent. It will be act accordingly. And these are the default system, like whatever the default system you wanted to say. So whenever you assign a certain task, it goes to the user proxy agent, and from that user proxy agent, it goes to the assistant agent. And uh, and the assistant agent will be given to the group chat manager will be used for the particular uh, group chat manager will be used for the managing all this particular user proxy agent and the group chat manager. So this helps us to manage this particular assistant agent and the user proxy agent. That helps us to configure the which agent to run and which agent to over there. uh just a second. Okay. So now we're talking about when human in a loop, how does exactly things work. As application user will be there, and then uh, this particular application user ask the question, and we have seen a group chat manager. That is nothing but the orchestrator for the agent, which agent to call when or that. So this is just a round robin group chat or there, where we given the ask to agent 1 and agent 3, and then a user proxy agent. So whatever the conclusion has been coming from the agent 1 and agent 3 are passed to the user proxy agent, and it is given back to the application user. And that's how this user input response over there, and this loop entire thing comes over there, and we get the final result for the model. So that's how this particular human in loop autogen would looks like. When we talk about this, the simple one, so there are different agent conversation can happen. So it could be serialization, hierarchical chat, joint chats, and other things. So that's what this particular slide talk about. When we have only a conversible chat, it's there or there. Uh, uh, that's what it is. And you could see the joint chat, there is a round robin happening between two different multiple agents over there, and it tried to give the input of one agent to another agent, and another agent to the initial agent. So it's go information goes round and round, and then final conclusion comes over there. Depends on how we wanted to terminate the agent, we could add into the code, and it could happen. Similarly, when it's like hierarchical one, where you could see the one task is given to the all different three different agents over there. That's how it's happening. And then when we talk about a multi-agent conversation flow, uh, so there where we could see the example over there, where we have a user proxy agent, and we are just given a task that we wanted to chat with the metas and other thing, and we wanted to get the final output. So it is like it try to generate the stock prices and stock prices between, and compare the two different stock prices and give the final output over there. So it tried to have the conversation, it tried to execute the code, it tried to install the libraries, and try to get the final output for it. And this can be seen in our upcoming examples that we will be trying to see. Similar to we have seen about the different use cases which we talked on our first slide about a different applications. So we could see the math problem solving or the retrieval augmented chat. If there is a decision making thing which you wanted to do with using a chat, or there is a multi-agent coding system where the writer and safeguard and other things who is trying to write the code and try to execute it. Where we have the dynamic group chat and also the conversational stage. So there is a two players playing the chess game with each other, and that's what we trying to see in that particular example. I think it's been more about theoretical. Now let's jump into the hands-on session, where we try to see that how exactly things work for this particular model. Uh, uh, we'll try to set up the utils for this particular things. I'm trying to use a GPT-4 or mini. The OpenAI keys are been there in this particular function which I wrote over there, and I'm just passing the LLM config over there. It's a very basic autogen agent which I'm trying to import it from autogen to conversable agent, and we're just sending any name specific, and whatever the LLM config which we have set up on the upper cell, we were trying to passing the same. So whatever the agents or the LLMs which we wanted to configure into the autogen, we could configure over here. So that's how we're trying to configure the autogen one. And so example, this is a very simple example that we are, so tell me a joke. So we are just asking the question, and you try to give the final output. So it could be any of the joke. Similarly, if you wanted to ask a joke and other thing, so it doesn't have the context of this, so it doesn't know that what exactly the joke was previously generated. Now we have seen that is a simple one, but what we have seen is the more of a conversation. So it's conversation happening to different agents, and how the things are being final output we are being getting over there. So when we talk about this, so there we are just um dummy names which we could use over there. So like conversible agent, or any name you could give is Kathy, and your name is Kathy, and you are stand-up comedian. So them trying to create a conversation between two stand-up comedians and how they are interacting with each other. So that's what we are doing. So there is one guy with the Kathy, and another guy with the Joe. So they both will talk to each other. So we are trying to configure this particular two guys, Kathy and the Joe, and we are just passing the system prompt over there. So we are stand-up comedian, and then probably and the next joke, whatever the joke which has been told by the Kathy, will try to Joe will try to understand it and try to reciprocate or try to generate a new joke from it. So similarly, it will be trying to have a max turn of two. So there will be two conversation happening back and forth. So that's where the particular max turn talk about. So if we see the conversation, the conversation happens between the Joe and the Kathy. So Joe is talking first, and then the Kathy is talking again. So and we have reached up to the maximum turn of a two, and we got the response from this, that there was a conversation happened between two different agents. And if you wanted to see the history of what happened has there, so you could also see that whatever the things has been discussed over there. So that's how we will try to use the chat history. Costing, this is for the more of a costing side of it, how many tokens has been used and other thing. And if you wanted to have a summary of the model, so we could get the summary for it. To get a better summary conversation, we could summarize the prompts. We could set up the methods as a reflection with LLMs, or the summarize prompts or there, so that we get the final better response or there. So Joe will be initiating this one, and the another is the Kathy which we are entering over there. This is the one which the conversation happened between two different person, Joe and Kathy. That's how we get the summarized discussion what they had been happened. So example, we wanted to have something like when do you want to terminate. So previously we have seen the example that was more of a hard coded related stuff, where we have the two messages sent, and then it could be blocked. So now it's more about the where when a specific word has been there over there, and then only it will get stopped. It won't stop only specifically on the two or the third letter of or third words of one thing. And then it will have the conversation, and as soon as as soon as we have the conversation, it will stop. get that particular word in the discussion, that so it will more of a conversation where as soon as the word get I got to go, then only that particular model will going to model will start sharing between them, so considering the time constraint and other things, probably we'll see with the so considering a time constraint, we'll stop that conversation and then we'll go to the customer, that it's more of a customer onboarding process. So there is a two customer proxy agent over them. So we have set up the one of the agent like a customer onboarding person agent. So we are setting up this onboarding person information agent, and whatever the system prompts that particular person has to do here, we are setting it that one. And then another topic from a proxy agent, and then whatever the agents we have created at the top, we are trying to set this up, and the recipient, what are the maximum turns for this particular agent will be, and these are the three different agents that we have created in the top. And that's how we start the onboarding process. So we initialize the chat, still wanted to close this chat. So there is a discussion happening between this onboarding person and other thing, and as there was a human loop over there and wanted to act over there, so that's why we use this particular onboarding customer proxy agent. So this could be it's just normal information because we didn't run too much of the data. So as soon as the more discussion happens, so that we could get a more detailed and brief discussion over there. And that's how this particular cost and other things agent is we are giving a task of blog post writing. We are writing a blog post on the deep learning with just 100 words. So somebody is writing. Generally what we do is the we write give to the LLM, and LLM just generate the output, and we have to work upon that one and then finalize it, and then as a human we have to do it. But he wanted to give to the auto agent, it tried to get certain blog post from it. It goes to the reviewer agent gives certain feedbacks to the another agent, and it try to get the refine the final output. So this is the one of the writer agent who will be writing the agent blog post, and then it just the normal one, but it doesn't have the reply over it. uh, Now we are just adding a reflection example, like another agent, like a critic agent. So probably who will be trying to read that blog and try to understand it and try to get the final result for it. And SEO reviewers, legal reviewers, at the top. So we are orchestrating this particular agents, and now we are triggering the all these nested chats for this one, and try to get this one. And so all the discussion is happening between this writer, reviewer, critics. You could see SEO review try to give the final output for this blog post, which is more about the deep learning one. So considering the time, you could see the similar techniques and what this particular. So the another building block we could see is a more of a tool building. So we talked about in initial examples about the chessboard, how the chess two-person can place a chessboard. So it's more of a creating a chessboard over there, and try to the two agents are playing a chessboard within each other. So we just taken the one module, and we are trying to create the chessboard. This is just for the for context. It's more about tool building. So this is the tool that we have created for the building a chess, so that you could see over there how the things are the move and how things are been moving over there. Now so we are defining a player one and player two. The player one will be the probably the whatever the moves will be there, it will try to have this. So and there is a board proxy agent, so who will be trying to help us and try to be act as assistant for this process. So we already, since we already we have already, if this tool was we have created by manually, so we have to register that tool. uh, and we have to configure that tool into system. And this is the to agent. So we could see let's play the game. Or see, you could see the of this one. So one chess is moved over there, and then another person is playing. So we have just kept nearly one or two moves over there. So that's why we stopped after the two moves. So you could see there how the agents are playing a chess with each other. Mm, adding a function to chit chat game. So this is more of a adding a functions. Probably will not try to go deeper into that one as of now, considering the time limit. So this similarly, when things are happening and there in between there is also a conversation happening in the between the game. So this of the tool building. So you could build any of the tool with the available things, and you could register your tool, and then it can be useful for your agent. So now going to this coding financial one. So probably we have seen that there is a coding tool. So this is more of a coding tool. So it we have given a certain task to it. It tried to generate the code, and it tried to execute the code for your models. So it's a local code executor agent which will try to execute the code, and this is the assistant agent who will write the code for us. So one person has to write the code, and another has to execute the task. So we are just given a certain message to it because it's more of a stock related stuff. um, Code executor, and what are the things we have, and let's see the plot. So it will try to execute the code, and it try to give the final output for the model. So it tried to get the response from this via finance over there. So you could see there is a different code over there, and then from that particular code, it tried to see the generated using this above code. So it tried to generate the comparison between the gain of Nvidia and the comparison between the Tesla. So this was generated with the code executor, and with the help of that, it tried to get the result. Planning a stock generation, planning a stock report generation, we could just have a simple task over there and try to get into this. Uh, so you are given a task to generate a stock performance, and you are just generating a report from whatever the engineers over there, and then the executor code and the writer. So it's more of a different agents that you could configure, and since initially we saw the different agents, so we are setting up the user proxy, engineer, writer, executor, and the planning. So this particular group manager chat will help us to manage the different uh, chat, and different agents will be revoked accordingly. And then we try to get the final result from it, and different user proxies and other things we have to configure. Where the conversation happening between, it's like a debate between two different pizza lovers, I would say. And it's more of a pizza lover that you having a pizza, and one agent is a pizza agent, another is a social media agent. Either one is once the word is that I have developed to launch that particular stream data, we have just tried the streamlit run over there, and then probably um, okay, so that we could get it. Now to get how do we deploy it? So a little bit more onto the hands-on session of deployment into the Azure App Service. So it's just the Streamlit app that we have created over there. We will use the Azure App Service for it. So it could see App Service. Okay, it's loading. So Streamlit app, which I've showed you, the Azure App Service I'm going to show, and then how we're trying to deploy this into the Microsoft Azure one. I created this one. You have to just configure it into the just block into the zip file app and the whatever things which we have. uh, so this is the developer code and the developer the code which we have there, and then we push it to the Azure web app. So we could see this particular multi-agent turn. We are pushing the code. So there is to make sure that you have to deploy it, you have the Azure subscription, the Python environment, and the Azure command line, because you have to deploy it to the Azure using the Azure command line. So whatever the Azure command line is, using this particular Azure login, we could do it, and then we could see the AZ logins and the different versions for it. So we'll deploy the code using this one, where we have this created requirement txt, the p-gen, and as I showed over there. So this is the requirement txt, the main app, and the util file which has my OpenAI key. we will deploy this using the containers, or we could also deploy it using the directly using the uh, zip file. So we could say that Azure Web App deploy resource group, and whichever my resource group is there, and the web app which I created, which you could see over here, the multi-agentic autogen one which I created. So we have to restart to, and we have to go into this particular path and post this app zip into this environment. And as soon as you deploy this one, you could see into the your logs. So your web app is up and running over there, and okay, so it's connected. So whatever things which could deploy in this particular using this uh, so generally this is the command for it. Whatever we could see as your web app deploy, I am not deploying it because it will stop my app and it will get restarted. So just to show it, like az web app resource group, which are the ml project group, which we resource group, and the web app name along with the which are the file we wanted to push it. So as soon as you push it, your code will be active. You have to set up the configuration for it. So configuration is help us to is like a startup command for it. So as soon as the codes is being uploaded, so what kind of a startup command so you could see the pip install upgrade or the requirement txt streamlit run, and which are the port we wanted to launch it. So this is the startup command. So as soon as you push your code, it has to execute this particular setup. And that's how we deploy our app. And once the app is deployed, we could see in this particular overview section. Mm, or we could second fine, it's and up now. So we could click it over there, and this is our app which is deployed now on the Streamlit. And we could see that this is a trigger. This is whether it's just a smaller pizza or the sushi. So we are just triggering a debate. As soon as you trigger the debate, you could see the things are stimulating, and similarly we could also see in the log stream as well. So things are happening, the discussion between the two different agents are happening over there, and they will come up with the final resolution for it. So you could see the what is happening. There's a debate happening between the pizza and the sushi over there, and what a discussion is happening, and that we could see over here. And as soon as they got the terminated, we could see okay, I think it got stopped, so let me regenerate it. Okay, probably we could get the output like this. I'm not sure what's wrong with that, but okay. So we could get this particular output like this, and how this particular debate results. So where is whatever the sushi level and other things. So it try to have the judge result. Thank you, sushi for gracious response. It's indeed important to celebrate or whatever. The NS pizza is the winner. So that's how this particular things is been there. So this is more about more about what we have created, and that's what you see. The final deployment of the our Azure web app. Okay. So that's it from my side. Anyone who has joined the live stream has any question or the query, probably feel free to ask. Thank you for today's session. Sudhanshu, are you there? Sudhanshu, are you there? Hello.
Yeah. Hi. Hello.
Yep.
Yeah. Okay. Thank you
Yeah.
so
Hi.
much.
Hi, Sudhanshu. Yep.
Yeah. Thank you so much, sir, for this insightful session. And thanks to all the attendees and the viewers who joined us for this exciting season of Agent Session. Now it's your time to discover, build, and shape the future together. Thank you, everyone, for joining. Thank you, Bhushan, sir, for your session today.
Thank you. Thank you. Thanks so much. It was great talking to you and have a great discussion with the community. Hopefully, community got benefited with this particular topic. If anybody wanted to reach out or wanted to have a discussion, so you can also reach out to me on my LinkedIn ID Bhushan Kapkar, and probably feel free to talk and feel free to discuss more about it. So let's think. Industry is shaping and agents are also shaping. We'll see more progress and more development on this agent side. Okay, fine. Great to give the talk and have a great conversation. Thank you.
Absolutely, sir. Suggesting everyone to check out Bhushan sir's LinkedIn, and if you have any query, you can connect with him. So thank you so much, sir, for this session again, and thank you everyone for
Thank you.
joining.
Thank you. Thank you so much. Bye.